Hello everyone. Today we are going to be talking about whether models are a good fit by using residuals. So like that, when you draw that trend line, you could see if that's going to be a good fit by drawing that trend line and then comparing the actual Y to the predicted Y. And we'll get into that right after this do now. It says label the scatter plots below with the correct terminology, and that's what we're going to do. We are going to look at the trend line right now on all of the scatter plots. It's drawn already. So this trend line is going up from left to right. So we know it's positive and the points are clustered around that trend line. So we are saying that this is a strong positive. This one is going down from left to right, down. We know that this is, and the points are clustered around the trend line, so this is a strong negative. Association. And then this one is going up from left to right, so we know that's positive. The points are not as clustered around the trend line, so that means this is a weak positive. Still going up, but not as clustered around the trend line. This, you cannot draw a trend line. There is no trend here, so that means we have no correlation, no association. This one is going down from left to right, but the points are not clustered around that trend line, so we say this is a weak negative going down. Remember, every time you have a trend that's upward, that is positive. Every time you have a trend that's downward, that is negative. And that is it. So just to get into what we're going to talk about, we're going to talk about residuals. The residual is the difference between the actual data. So we're talking about the actual points and the predicted value. And we're only going to focus on the Y values, right? So the residual equals the actual Y minus the predicted Y. So it's actually, you're going to take the one that is definite point and subtract it, and subtract the predicted Y from it. So this is how it works. I'm going to take the predicted and put them in blue. So this is my trend line here in the scatter plot, and the actual points that were given, there were only 2 actual points that were given on this trend line that I drew in the scatter plot, and so I drew the trend line through the center of those 2 points. We'd never have a scatter plot like this, but just for demonstration purposes, this is what kind of I put together. So these are the blue predicted Y's. The predicted Y's really just on the trend line. So now I can make other predicted Y's right here. I can predict, and right here, and right here, and right here. So you can see those points are predicted. They're not actual Y's, but the red points are the actual Y's. So you take the actual Y and you subtract it, and you subtract it with the predicted Y. You subtract the predicted Y from the actual Y, and then what you get is this point, this difference right here. And that difference is known as the residual, right? So if it's a positive residual, that means it's above, the actual Y is above the trend line, the predicted Y. If it's a negative, which is the difference right here of these 2 points, that means the actual Y is below the trend line. A trend line is an estimation, remember. So that's exactly why you're not taking, when you draw a trend line, it's just we're calling it a prediction. So when you draw that trend line, it's not actual, right? So regression lines are better because they're more exact. And that's why when we have the regression, when we come up with a regression equation, linear regression equation, that one is a little bit more, it's better. All right, so it's more exact. So calculating the residual will show how far the actual y coordinate is away from the trend line, the predicted y. And we're going to get right to it right now by looking at this scatter plot right here. So we're gonna put these points on this scatter plot, and I just want you to realize that these are the actual y's. These are the actual points, right? These are the actual points. So this is 1, 2. We're going to put it here. We're going to put 2, 1 right here. And we're going to put 3, 3.5. These are the actual points. 4, 3. And 5, 4. And we're going to draw our trend line. When we draw the trend line, we're going to try to draw it through the center of all these points. And I'm doing my best right there. Like I'm thinking, okay, I'm starting here. I could start it from 0, 0 and go through the center of these points. But then this point would kind of be left on that below it. And so I didn't want to do that. So I'm starting at the 1 and going through the center as best as I possibly can. And then actually hitting this point over here. Okay, so I drew the trend line. Now I'm going to list the regression points. But before I do that, I'm going to just go along the trend line and just put a point here. These are predicted values, right? Put a point here, put a point here, and put a point here. So you notice, like even before we actually go and figure out what the regression points are, you see this right here going up. This in the red is a predicted value. The blue is the actual. So if this point right here, we're going to just kind of go up right there. This is going to be the residual. It's the difference between the actual and the predicted. All right. So when we list the regression points, we are actually going to list the predicted points. All right. So we're going to just go ahead and put 1, and then let me just put this red back right here. And that's 1.5. So I'm going to put 1, 1.5. These are predicted points. And then we are going to go to 2, and we're going to see like 2, maybe 2.1. And then we have 3, about 2.8. And then we have 4, maybe 4, 3.4. Yeah, 4, 3.4. And then we have 5, 4. So those are the predicted. Here are the actual y's. So I'm just focusing on, I'm going to put the highlight on. I'm focusing on this, the actuals, the actuals, the actuals. Then I'm going to focus on this, the predicted y's. So you really don't have to look at the scatter plot from here on in. We're going to take the actual y, which is 2, and subtract 1.5 from it. So we have 0.5. And it makes sense because this should be a plus. And it is. This is a plus because it's above, the actual point is above the predicted, which is the trend line point, right? So now we're going to take this one, it's a different color, 1 minus 2.1. And you take a look right here, do you see this? See how far down the actual point is than the predicted point? From the predicted point, that means we're definitely going to have a negative, and we do have, when we subtract 1 and minus 2.1, it's negative 1.1. All right, now we're going to go to this right here. So we did these two. This is 3.5. And we're going to minus the 2.8 from it. And we get a 0.7. And you just take a look. You see this right here? So this was negative. This is definitely going to be positive. And yes, it is a plus, a positive 0.7. You see how far this was from the actual trend line? All right, that's why it's further from 1, the distance, negative 1.1. That's a far distance away. This one is not so far. It's not as far, I should say. And then that's a 0.7. You see this one right here? This was a 0.5. That's even closer to the trend line. So the closer to 0 you get, the truer the value. All right. And so I'm just going to put the dotted lines here. So this one should be like really close, right? So it should be close to 0, but it's definitely going to be a negative because it's below the trend line. So we're going to take the actual. We took the 3.5 minus 2.8. Now we're going to take the 3 minus the 3.4. See, it's going to be negative, and it's a negative 0.4. Our closest yet. But then we have this one right here. So we have the actual at 5.4, and we have the predicted at 5.4. So we're going to take 4 minus 4, and we're going to have a perfect spot on 0. Right? No, basically 0 residual means that the trend line, the predicted value, and the actual value of y are exactly the same. So you could think of residual as how far off each predicted value, the points on your trend line, your line of best fit, are from the actual values. And just remember, a positive residual means that the actual point is above the trend line. And I'm sure this says on the bottom right here, a negative residual means that the point is, the actual point is below the trend line. So we'll kind of go over that really quick. And I was doing it before on the page before. See this right here? This is the predicted value. This right here is the actual. And in between, that's the residual. If it's below, that's going to be a negative. This is below, that's going to be a negative. The predicted values on the trend line, the actual value is up here. This is the residual, and this is a positive, just going to be a positive residual right here. And I have an arrow pointing that this is going to be the residual. This is going to be a positive. And then let me move my face over here. And then this is going down right here. So that means that the actual is right here. The predicted is right here. The actual is below the predicted. So that means it's going to be a negative residual. And that's really everything there on that page. All right. So calculating residuals and creating a residual plot. This is where sometimes it gets a little bit tricky, but I think you could do this. This is going to be easy for you. All right, here we go. The first thing is step 2. It says, step 1, calculate the residuals. But I'm just going to go to step 2 because it says calculate the equation for the line of best fit. You have to know how to do this by hand, but we're just going to go ahead and see how we're going to do this. This is a 20. So right here, this is 20. This is just easy. That's why I'm starting with it. I'm going to make another point here Do you see how these are predicted points? These are predicted. That one matches that one. That one matches that one. Predicted points all along the bottoms of this. So I'm just going to go ahead and draw my little triangle for rise over run. So I'm going to have a -2, and then this is a 1. And this is in millions of dollars. I put that M there. It's -2 million. So I'm going to have to put that in the equation. And that's going to start at 20 million. That is the equation of the line of best fit. And then we're going to go over to here. Okay. So remember, these are actual points. All right, look, 119, 119. There it is right there. You see that blue? I'm going to put that blue right here. That's 119. 215. That's this. 313. That's this. These are the actuals. So you understand that these are the actuals. And by the way, that's an actual. That's an actual. And in predicted, that's an actual. These are actual points. All right. So we have 8, 5, and that's about it. So we're going to put predicted y values for this x. So 2, add 2. I'm sorry, we'll go to the first one. 118. Do you see that right there? And this right here, this point right here, this is a predicted value. So we put 18 down because the y is predicted and it's, on that trend line. So 2, 15 is the actual, but 2, what is the predicted? So 2, 16. 3, and we're going up to the trend line because we're looking for the predicted values. 2, 14, it looks like. And then 4, and we're talking about 12. Close enough. And then 5, 10. That's perfect. 6, 8. That's perfect. 7, and then we have 6. And then 8, to the predicted 4. Okay. So now we take our actual minus the predicted. So we're going to take our actual, which is 19, minus 18, and we're going to get a residual of 1, a positive 1. Now let's go to look at that 119. Right? 119 is here. This is an actual point. And then 118 is here. All right. So the actual is above, and that means you get a positive number. So let's just take a look. We're talking the actual, 15. Minus the 16, the predicted, and that is a -1. And when you look at it, you see the actual point is below the trend line, so that means it is a negative. All right, we're just going to go ahead and take the actual, which is 13, minus the 14, and we are going to get a -1 again. The actual, 11 minus 12 equals -1. And you just take a look. See 4. See how these are all below? The blue points are all below. The actuals are all below the predicted. That means you're getting negative. So now you're getting a negative residual. So this is 10 minus 10. This is where it is right here. 510 is the predicted and the actual. So it's 10 minus 10, so it's right on that trend line, and it's a 0. And the same thing, 8 minus 8 for the next point. You could see that the trend line and the actual and the predicted, they're exactly on the points. So it's 8 minus 8, which is 0. And then, so now we are going to go to 7 minus 6, which is equal to positive 1. And the reason why it's positive 1 is because this part right here, this point right here, is above the trend line. And again, we're going to have a 5 minus 4. Again, above the trend line, so it's a 1. Okay. With a residual plot, it's a little bit different than what you're used to. A residual plot has an X and Y. So the residual plot, you're graphing the actual Y's, the actual X's, and you're also graphing, and let me make sure this is on, you're also graphing the residual itself, this number. So when there's an actual X of 1, the residual is 1. All right. So I'm gonna go back and forth with this, and maybe let me change the view so you could see both. Let's see if I can do that right there and move my face to the middle. All right. So when the X is 1, the residual is actually 1. I'm gonna put some numbers here on the okay. All right, so I have, like, right here, I'm gonna put 1 here, and I'm gonna put 2 here. I'm actually going up on the Y's. Like the residual, I don't have to have a large residual, because if you look at all my residuals right here on the right side of my graph, I'm not going above 1 or below -1. So I'm just going to put -1 here. And I'm going to actually go to -2 here, even though I'm not going to go above and below that much. But that's it. So this right here could be 9. This could be 10. This could be 11. If you went up that way with the, that grade on the x-axis, you would continue by 1s. But this x-axis is only going up to 8. So the actual x that I'm going to plot is 1, and then the residual is 1. So 1, 1 would be right here. This is my residual plot. Then I'm going to go to 2 on the x-axis, and the residual for 2 is -1. So I'm going to go down, just like that. Hopefully you could see that. All right? Then I'm going to go to 3, -1. So 3, -1, right here. 4, -1. And this is basically showing how far your actual data and predicted data are from each other. So this is 5, 5, 0. I'm going to put it right on that point. And then 6, 0. Right on that point. So the zeros, remember, that's when the actual and the predicted are straight on with each other. All right. So 7, 1. 7, 1. And then 8, 1. 8, 1. All right. So there is your residual plot. This is the next question that they always ask. They ask, does the equation modeled in the data, does the equation model the data in the table? Is the model a good fit? And I wanted to type this, and then I'll go over it with you. Do you see how the residual plot right now, there is no trend? There's no like shape or pattern, like a U shape or something like that. If there is no pattern for the residual plot, we say that that suggests that the trend line is a good fit. So no pattern, good fit. Pattern like a U shape, bad fit. That means the trend line is not a good fit. When you're talking about drawing a trend line, it has to go through the center of all the points. So you're taking a look at this scatter plot right here, and that right here, this trend line that was drawn, is a pretty good fit. You could see it. So that's why the residual plot has no pattern. And you're just looking at it, and there's points up, below, right on, up again, right? So we're saying that the pattern in the residual plot, there is no pattern for this residual plot because the trend line's a good fit. If there was a pattern, not a good fit. And we'll see what a U shape looks like and what not a good fit looks like. And that's about it for this one. Hopefully that kind of worked out there. Step one, remember you always calculate the residuals and the actual Y, the actual X. We're taking the predicted Y and the actual Y and subtracting them. And this is just another form of what we did on the page before. And this right here is the residual plot where you take you're plotting your residual, and if you're putting points down, you're putting your numbers down to label, you're just going to go up to 1. That's the reason why I went to 1 here and 2 here, because take a look at my residuals. My residuals are the Y, right? So I'm not even using -2. That's why I'm not going down to -2. I don't have a residual that's greater than -1. All right, or less than -1, or greater than +1. So remember, and I did this on the page before, the actual X is really what you're looking for here. The residual is what you're focused on. And when you go ahead and you're plotting your point, you're taking the actual and the residual, 1, 1. That's why this is 1, 1. That's why this is 2, -1, 2. The X is 2. And at that point where the X is, how far is the trend line, the predicted Y, from the actual Y? All right? The actual Y and predicted Y, you subtract them. And that's what you get, this -1. So then you just go, you keep on going. You go to +3, -1 again. And then 4. -1 again. 3 -1s. And then right spot on. Spot on. Right? This point and this point. That's what you're graphing when you're talking about a residual plot. 7. You're taking the actual X and then taking the residual to plot that. So 7 is +1. And then 8 is +1. No trend. No trend. Right? Not a U shape, not anything. So that means that the trend line is a good fit. So we can go on right now. This is calculating residuals and creating a residual plot. So these are the actuals. Actual points. So look, 35.42. 35.42. Right there. 37.44. 37.44. And you see what I'm saying. These points are actual points. The trend line is going through the center of those points as best as possible. Right? You're looking at this and you're saying, all right, that trend line, actually, when you take a look at that trend line, I don't even know if I would draw that trend line. But in this purpose, we're just kind of like saying, okay, that's the trend line. So now we're going to calculate the residuals. So let's go down and we're going to calculate the residuals. So I have everything done for you. All right. So we have these actual points, actual X, actual Y, and here's the predicted value based on this trend line. So the predicted value is 45 when X is 35. Let's see, 35, 45. You see that right there? That's a predicted value. When the 37 is right here, we have a 45.4. So these are predicted Y's that are already figured out for you. So all we have to do is to actually subtract the actual and the predicted to get the residual. So let's go ahead and do that. So we're going to we took the 42, the actual Y, subtracted the predicted Y from it, and we got a -3. Right? This is showing how far the actual values are and the actual and predicted values are from each other. So we have a 44. So we're going to put the 44 down minus 45.4. And every time that you subtract like this, if you need the calculator, you get, and it's a -1.4. You just put this into the calculator and you get going like that. So we're going to take this and this. 47 minus 46.2. And we are going to say that that is a 0.8. And then we're going to get 50 minus 46.6. And we're going to say that's a 3.4. 52 minus 47. And we're going to say that's 5. 51 minus a 47.4. We say that's 3.6. And 49 minus 48.6 equals 0.4. And a 45 minus 49 equals a -4. All right, so we took the actual Y and we subtracted the predicted Y from it, and we got the residual. So I'm going to highlight what's going to go on our residual graph. All right, a residual plot it's called. The actual X and the residuals. All right, those numbers. So let's go ahead and plot. I have the plot set up from 35 to 55, and actually you probably should be a little bit of a break here that I didn't put, but it's because you're skipping to 35 and then going by twos. So that's what I went by. And then the residuals, I'm really looking at this 5 right here. So that means I had to cover all the way up to 5, and this is -4. So you should probably put -5 here to balance it out, even though you'll never use it. Okay, so now let's go ahead and plot these residuals. All right, so 35, -3, right down here. 35, -3. 37, -1.4. I'm going to put it right here. 41 and 0.8, which is right about here. And then 43 and 3.4. 3.4 right about here. 45 and 5. 45 and 5 right about here. 47 and 3.6. 3.6 right about there. 53 and 0.4 about there. And then 55 and -4 right about there. All right, take a look at what you have. And the first thing that they're going to ask you after you finish your residual plot is, does the line of best fit model the data in the table? So they're asking you, is the trend line good? Right? Is it bad or good? Now take a look at what we have up here. Just want to remind you what this trend line looked like. That trend line, to me, I don't have to create a residual plot to tell you that that trend line is not good. All right, this trend line is really, it doesn't go through the center of all the points. There's some points above and there are some points below, but again, it's not something that is a pattern that you could even draw that trend line. But the trend line was drawn, and now the residual plot looks like this, and this represents a pattern. So a pattern, remember, this is not a good, the trend line is not a good fit. Is the line of best fit model the data in the table? No, it does not, because this is a pattern. It creates an upside down U shape. And when it creates an upside down U shape, you know you do not have a good model for the line of best fit. And that's what I was typing there. No, the line of best fit is not a good model for the data in the table because it creates a U shape. So if you are absent and you want to copy that down, this is exactly how you answer a question like this. No, the line of best fit is not a good model for the data in the table because it creates a U shape. And that's it. That's it. So we take a look at this right here. This is obviously right from the start, we knew that that trend line was not a good fit. Really didn't make any sense. Then if we go back and just take a look at this table right here, this residual plot, where it doesn't create a shape, a U shape. This is a good fit. And then this one would be an example of something that would not be a good fit. Right? The residual plots, if they have a pattern, that means it's not a good fit. The trend line is not a good fit. If they don't have a pattern, that means the trend line is a good fit. And that's it. All right, because we're doing two curriculums here, we're going to first calculate the equation of this trend line by hand. And obviously there's no trend line here, so I'm going to draw that trend line right now. So I'm going to start right here, and I'm going to draw that trend line right here like this and go try through the center of that point right there. And yeah, I think that looks okay. So I try to start the trend line like at a number that is just easy. If they're asking for me for an equation, I'm just going to try to do the best I can to give myself like a y-intercept that is easy for me to identify, and right there is my y-intercept. I can actually move that a little bit below, but I'm going to leave it at 20 and see if I'm going to actually move it just a little bit below. Let me move this out of here. So I'm going to move it right there, maybe. All right. So instead of 20, I'm going to say that that's 19. I'm just trying to be as cautious as possible, and right there. So you see that's like right below 20. And I'm going to put an arrow up here, and that's my trend line. So now I have to calculate. Remember, in 8th grade, you don't have a graphing calculator. So we're going to calculate this slope by hand. So I'm going to scan this trend line for a good point. And starting with my y-intercept, it was 20, but I'm not going to start there. I'm going to start right here. This is a good point. I could use this one. All right, and I could, let me scan, and right here. like I said, if I don't have a good trend line, if I don't have a good point that's on the trend line, you make that point. So I'm going to go ahead and say this is 3, this is 5. So we're going by ones, 1, 2, 3. So that's 3. And then we're going by 5s. This is 35. So 5, 10. So this is 10 over 3. So 10 over 3. And a lot of people get confused. When do I, because sometimes we divide the rise and the run. Sometimes we don't. On a trend line like this, we're always going to divide the slope. Like, we don't need rise over run, right? So we need what we have right here. So we're going to have a 10 divided by 3. We're going to look at 10 divided by 3. And we're going to round that to the nearest 10th, let's say. We're going to round it to the nearest 10th. So we're going to leave it 3.3. So this equals 3.3. So we have 3.3 x plus 19. Okay, that was by hand. And that's, if you were doing this in the 8th grade, you would get 100%. You're showing your work right over here. And that's it. But now, 9th grade, calculate the equation for the trend line and then use your calculator to do it. So it's a little bit different. So we're going to calculate the equation for this trend line by using the actual points, and we're going to use our calculator to help us out here. All right, we're going to do this on the fly. When I say on the fly, I mean on the fly. So we're going to clear this out right now, and we're going to go and press stat, and we're going to put this in a list. And my lists have been cleared already. So if yours aren't, remember, go up to L1, press clear, and then enter. Go up to L2, press clear, and then enter. All right. If you delete one of the lists, that means, remember, you have to go to stat and then setup editor and press 5 and then press enter to get that list back. So we're going to press stat and then enter for the edit. All right, so we're going to have 1, and that is, let me just move this over just a little bit. So 1, and then that's 20. So that's pretty easy. So 1, we're going to enter it, and then we're going to go over here. Usually, typically, I don't try to, I don't want to do this like this, like entering X and Y, but in this case, we're going to have to do it because we're doing it on the fly. So this is 1.823, 1.8, and then enter, that's the X. And then 23 is the Y for that one. And then just take a look at your calculator that you're entering it correctly. So now here's another point. This is 330. Yep. And then 433. So you just don't, make sure you don't mix up the X and Y's. 433. And then we're up to 5. So that was 433. And this is 5. I would say 539. And then we have 6. Let me get that out of there. Was that a point? Let's see. Yes, it was. Just wanted to see if that was a point. So 640. Enter. Then over 40. And then 6 again, because we have 6 and 44, I would say. All right, and then we have 743. And then we have 7 again and 47. All right, and then we have 8. 48. And we have 9, 50. And last one, we have 1050, basically. All right, so all of our numbers are in the list per stat. And then we're going to go over to calc. And we're going to go down to linear regression, which is 4. And we're going to press calculate. Press enter like 5 times. And we see that we have this. All right, so let's go ahead and put this in. The A is your slope, which is 3.6, rounded to the nearest tenth. And then the 18.7, that'll stay. So we're going to move this over, and we're going to put this 3.6 down. Not bad. 3.6, and then 18, we're just going to put this on, always on front. Oh. And just, if you do that, and you want to get back to it, just press 4. The list is still in there. And then enter, 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 enter. And then there we go. That's 18.8. So this equation from the calculator would be 3.6, which is pretty good. 3.6 and 3.3. That's kind of close. And an 18.8 is really close to my 19. So that's really good. Was your equation close? Yes, it was. Yes. I'm great. You're great. All right. So, that's really the difference between 9th grade and 8th grade. You have to do things by hand in the 8th grade. 9th grade, you would use your calculator, graphing calculator, to give you an equation that is very, very close for the trend line that you would have to draw. So there's something called R in the calculator that hasn't shown up yet, and it's called the correlation coefficient. This value tells whether the correlation is a positive or negative trend, and how closely the equation models the data. All right. So the correlation coefficient, let me just go to the next page here. The closer you are, the way this works is that the closer you are to 1 or -1, the stronger the correlation. So the closer you are to 0, the weaker the correlation. So I made this chart right here, and it's really just saying that this right here from -0.5 to 0 is a weak negative. From 0 to 0.5 is a weak positive. This moderate positive, 0.5 to 0.8, that's a moderate positive. And this is a -0.5 to -0.8 is a moderate negative. And then anything above from 0.8 to 1, and then -0.8 to -1 is either a very strong negative or a very strong positive. And to get these numbers, you must turn diagnostic on. And this is one way to do it. You could press second, 0, and then down to diagnostics on, and then enter twice. Or I like to just use the calculator right to turn diagnostics on this way. You just press mode, right? You see stat diagnostics. It's off right now. I would go down to that, stat diagnostics. Oh, righty. That's not good. Stat diagnostics. And then when the off is blinking, just go to the right, and then the on will be blinking, and then you press enter, and then stat diagnostics is on. So the other way to do it is to just press second and then catalog, and then go down and just keep on going down until you see Diagnostics. All right. And once you see Diagnostics, then you could just basically, there is a way to get there faster than this. And then you could just turn Diagnostics on. All right. And you see right here, it says Diagnostic off and Diagnostic on. So if you turn it off, that's you press enter there, you turn it off, you turn it on, you press enter, Diagnostics on, enter, done. Right? The mode, I think, is easier way where you can get down to Stat Diagnostics pretty quickly and then just see that it's on or off. Every time you reset your calculator, it does reset it to off. So just make sure that you are turning Stat Diagnostics on in the beginning of the test. All right. After you reset your calculator, just go to mode and then go down to Stat Diagnostics, turn it on, and then you're ready to go. So one of the questions, we did calculate the equation for this trend line. So I just want to make sure that you understand that you're following the bullet points. We found the slope and the y-intercept, and we put those down. And it says calculate the correlation coefficient, and that is R. So just remember the R is called the correlation coefficient, and I did mention this. The value tells whether the correlation is positive or negative and how closely the equation models this data. So there's a way to get this into from your calculator, and just remember you do have to turn Diagnostics on. Always remember to put mode and then Diagnostics, Stat Diagnostics, it's on. You can see it right off the bat there, and press clear. When you remember, we put these points from these the points into the L1 and the L2. That was from the scatter plot that we were actually working with. So then we press Stat, and since Diagnostics are on, you would go straight to Calc and 4. So it's the same, these are the same steps as we used to get the equation, the linear regression equation. But now we're just going to go through the motions of doing the same steps. But since Diagnostics are on, we are going to notice another two numbers. Instead of just A and B, we're going to have R squared and R. The R is the correlation coefficient. All right. So we're going to round this to the nearest hundredth, and we're going to put 0.97. So we're going to put R equals 0.97. And we're going to that is the correlation coefficient. And when you get that number, that 0.97, I just want to refer to this right here. 0.97 is very, 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 very close to 1. So the closer you are to -1 or 1, the stronger the correlation, right? So this is a very strong positive correlation between keyboard speed and experience and keyboard speed, right? So you would say that this is a very strong correlation. There is a very strong correlation between experience in weeks and keyboard speed. And I took the time, we're going to go over this more. So like if you don't understand it right now, just remember the correlation coefficient's coming up on your calculator, right? As long as you have Stat Diagnostics on, the correlation coefficient will come up on the calculator. It'll come up exactly how you got to the equation, the linear regression equation. It comes up exactly right on that screen. So that's the good part. There's nothing else to learn as far as the calculator is concerned. The correlation coefficient is telling whether or not it's a positive or negative, and it's a good, what kind of correlation you have for this model, this data, right? So of 0.97, and let me just go to this to this page again. Remember, 0.97 is in this green area right here. So we say that it is definitely a very strong, this correlation coefficient of 0.97 means that there is a very strong positive correlation between, and then you just take the experience, whatever's written down here, experience in weeks, and keyboard speed, which is right here on the y-axis. So this correlation coefficient of 0.97 means that there is a very strong positive correlation between experience and keyboard speed. And that is it. All right. You do have to remember, nobody's going to give you that. So they usually do give you, they don't kind of ask, they either ask you a very strong positive or very strong negative, or some other question like with a weak negative or a weak positive. Just remember, 0 to negative 0.5 and 0 to 0.5. Those are weak negatives and weak positives. The 0.8 to 1 and the negative 0.8 to negative 1, that represents a very strong negative and a very strong positive. All right, so correlation could be positive, negative. Tell how closely the equations model the data. The closer you are to 1 and negative 1, the stronger the correlation. I don't like pressing second 0 catalog, go down to diagnostics on. I just like to bring up the calculator. I have my calculator here. I press mode. I'm in the mode screen. I could tell right away that Static Diagnostics, which is down here. I could just go straight down to Static Diagnostics and turn it on or off. All right. So this would be turning it off, and then this would be turning it on. So when you create when you reset your calculator, like I said before, it goes to, it's by default turned to off. And that's not a good thing, because then when you are asked on the regions to to have that linear regression, when that Stat Diagnostics is off, that correlation coefficient is not going to show up. It's going to just have the A and it's going to give you the linear regression equation without that correlation coefficient. All right, so just remember, turn that Stat Diagnostics on to see that correlation coefficient. All right, let's talk about this. Use your calculator to determine the linear regression equation. Go ahead and see if you could do this and kind of create your X and Y table. Just remember that these points right here, this 420, we want you to put the actual points. These are the actuals. Right, so 420, then 430 would go here. And just go ahead and fill that out. And then when you're ready, and you finished, and you're ready for the next step, just press play. All right, so press pause and fill out this table now. Okay, so we have our table here. Just check if your actuals kind of match mine, and then we'll go ahead, bring up the calculator, and we're going to just practice putting these in. Just remember, if you need to get these, like if you want to kind of clear your list, you going up to L1, press clear, then press enter, and then go to L2, press clear, then enter. Don't press delete. If you press delete, then you have to go to that setup editor to actually just go back and get that L1 back. All right, so I'm going to put these, all of these into my calculator, and then we'll come back. So do that and press pause now. I just wanted to show you, when you have an X, when you have all your X's down like this, I just put into the calculator all the X's first. I don't go back and forth like that other one. So like the other one we did when we were doing it on the fly. So when I know I have 3 12s and then 3 16s, I'm good to go. Just take a glance at your calculator screen, because if you're doing something wrong, you can delete just that number. All right. So, and then I also, when I put this down, you see it says L112. Well, L112 means that I put in 11 numbers, and the calculator is waiting for the 12th number. I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I did that. That's correct. Then I could go over to L2, and then press 20. I have 120. I have 2 30s. Then I have 140, 150, 2 60s, 170, and just like this, 2 90s. It's nice and easy when you do that, and then the list should kind of be focused and like even on each side. I meant so if they're not, that means you made a mistake on one of the lists. So let's go to stat. We're going to get the linear regression equation, and we're also going to get the correlation coefficient, even though it doesn't say that right here. So we're going to press stat. We're going to calc, and then we're going to go down to 4. Remember, my stat diagnostics is still on, so once I press calculate, I should see the linear regression equation and the correlation coefficient, which is true. All right, so I have this right here. This is 4.93, which would be, if you round it to the nearest hundredth, would be 4.94, and then this is a negative 2.85. So the linear regression equation is y equals 4.94, rounding to the nearest hundredth, and minus 2.85, rounded to the nearest hundredth. You can see the A and the B right here. So I'm going to put down the R. The correlation coefficient is 0.92. Even though they didn't ask me to figure out the correlation coefficient, we have to get used to doing that. Y equals 4.94x minus 2.85. And this correlation coefficient, if you take a look, R equals 0.92. And just remember, you try to remember that this right here that I made up, 0.94 would be right. It is 0.94? No, it's 0.92. But you could tell right now it's within this area right here. So that 0.92 would be a very strong positive correlation. That would mean a very strong positive correlation between whatever is happening on the X and the Y. So that's what I put down here. There is a very strong positive correlation between the years of education. So just kind of like write down, hey, wait a minute. Here's the X right here, years of education and annual income. Right? And by the way, just make sure that you're putting the annual income is in thousands. All right. And then that you're putting that is in thousands. And then the same thing with this. All right. And we're going to go on to the next page right here. So calculator often gives this R. We know this. The R means correlation coefficient. In order to see that correlation coefficient, you have two ways to actually do it. You could go through these steps here, where you could turn diagnostics on with the second, pressing the second, which will open a catalog, second 0, and then alpha and then negative X is X to the negative first would fast forward to the D's. How you would do that, I just want to show you both methods, and you pick the one that you want to use. Second function, and then 0 would bring you to the catalog. Now, you could either go down, press the down button a million times to get the diagnostics, or you could press alpha, right? And this A has to be there for you, just kind of remember, just like that alpha is there. And so just when you press second function catalog, you see how this A is there automatically? So it is there automatically, so you don't have to press alpha. So when you're seeing the A, and then you could go to the D, see this where X to the negative first, there it is in green, the D, and you could go like to fast forward to D's and then go down right here, diagnostics on. It has to be on. You press enter and then you press enter again and it says done and diagnostics is on. The way I like and the way I use all the time is to press mode. And then you can see right now from here, Stat Diagnostics is on. If it's not on, you could go down to Stat Diagnostics, and right now I just turned it off, and then I could just switch it to on. All right. And if you move up, you could tell that that is the highlighted, off is not highlighted anymore, on is highlighted. So your Stat Diagnostics on. Remember, to see correlation coefficient, all that Stat Diagnostics has to be on. And that is it. So trend lines are estimations. We know that, but regression lines are better because they're not estimates. So use your calculator to find an equation of the line of best fit. Remember, identify and interpret the correlation coefficient. Reminder, diagnostics must be on for you to do this. So put these numbers in right now. So we're going to put these in as X. So put the X's in first, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then put this in as L2. So the ticket sales will be L2. The years would be L1. So go ahead, do that, press pause now. So I have all of my data in L1 and L2. I have my calculator right here, and so we are going to figure out the linear regression equation, and then we're going to figure out the correlation coefficient, the R. So we're going to check, remember that diagnostics is on, so it is. So we're going to go back to stat, and then we're going to press calc, and then we're going to go down to 4, or press 4. You press enter 4 times, and there are your numbers. So we have the slope, which is right here, the A. So the A equals 1.5. That is my slope. So my A is 1.5. The B, which is the y-intercept, is B, which is 16.3. And then the R, the correlation coefficient, is your 0.97, which we're going to round it to the nearest hundredth, 0.98. And since we're rounding to the nearest hundredth, I'm going to round this to the nearest hundredth, and this stays 1.5. So I just wrote that all down. So I'm going to erase this because it's not A. So we're going to get the linear regression equation as 1.5x plus 16.32. Just like that. So the R is correlation coefficient of 0.98. So taking a look at 0.98, there is a very strong positive correlation between years and ticket sales. So that's how you state it. There is a very strong positive correlation between years, the number of years, and ticket sales. So I'll write that down, and that's it. Very strong positive. All right. All right, here's this is an example of a Regents question. Use the data below to write the linear regression equation, and then they have you create a residual plot on the axis below using the residual scores from the table above. All right, so pretty easy because they actually give you this right here, and they did subtract the actual and predicted already, and they gave you the residual. So you would just have to know how to put this in to the calculator to get the equation and then to create the residual plot. Right now we're going to put in it says use the data below to write the regression equation for the raw test score based on hours tutored. So what we're doing is we're taking this and inputting this as L1 and this is L2. And then we're going to get an equation, and it says round all values to the nearest 100. So that's important that that you actually follow those directions. When I go back to my L1 and L2, you notice I have to clear my list. So go up to L2, press clear. Go up to L1, press clear. And then press enter. So now we're going to have 1, 2, 3, 4, 5, 6, 7. So we're just going to put 1, 2, 3, 4, 5, 6, and 7. Then on L1, we're going to have 30, 37, 35, 47, 56, 67, and 62. All right, we're going to press the stat, and then we're going to go over to calc. We're going to press 4. We're going to press enter 5 times, and we're going to get those 6.32. Let me move this over. Okay. We have just get this over here. This is the equation. So we have the y equals 6.32 x plus 22.43, rounded to the nearest 100. I'm just going to put the r down as 0.95, although it doesn't ask for that. All right, so actually I'm not going to put it down. Unless they ask for it, then you don't put it down. So it says create a residual plot based on the axis below. So just remember, when you're putting that residual plot together, you're taking this right here. Let me just highlight it again. So the x hours, the tutored hours, and the residual. So it's really, really nice of them to put the residual plot and the numbers together there for you. So if the numbers weren't there, just remember you have tutors hours. So like you're going to put from, like you're going to go from ones on the x's because you have to cover up to at least 7 right here. And the residual goes to negative 6.4, 6.6. So going up by ones kind of makes sense for this. So we're going to put 1, 1.3. So that's right there. 2, when the x is 2, the residual is 1.9. So we're just going to move it up to there. And then 3, negative 6.4 down to here. So just remember, negatives work a little bit differently than positives. It's past the negative 6 and closer to to the center of negative 6 and negative 7. So we have 4, negative 0.7, which is right about there, covering the 4. 5, 2. 5, 2. When x is 6, the residual is 6.6. So that's way up there. And then 7, negative 4.7. Should be right about there. All right, just based on the residual plot, now you have to state whether the equation is a good fit and justify your answer. Just taking a look at that residual plot, there is no pattern. So again, it doesn't create a U shape. They're randomly dispersed on the residual plot. So that means it is a good fit. And that is it. Okay, so that was an example of a regions problem. So try the exit slip. Which statistic would indicate that a linear function would not be a good fit to model a data set? So go ahead, try to answer this question. So they're asking which statistic would indicate a linear function, that would not be a good fit to model the data set. Try this problem, circle your answer, press pause now. Hopefully you picked D as your answer. It is not a good fit because it creates that U-shaped pattern, and we went over that during our lesson. The A, the residual plot right there, is a good fit. There's no pattern, equal amount of points up and down, no pattern at all. Very strong positive correlation with that correlation coefficient of 0.965, and a very strong negative with that negative 0.1. So A, B, and C would be good fits, and D would not. And that is it for that lesson. Hopefully you gained some knowledge here about it and were able to go over some things that you missed in class. All right, and that's it. Thank you for watching.